Hello, so this is the second video for the week of the 29th of March, and this one you should have just watched the sample space diagram video. This one now is about tree diagrams. So this is part one of a two-part lesson. So in this lesson we are going to be looking at drawing tree diagrams and calculating independent probabilities with them, and then next video, you're going to be looking at dependent probabilities. Okay, so, and if we link them to kind of grades, grade 3 is being able to draw and label a tree diagram, grade 4 is being able to calculate independent probabilities, and then grade 5 is doing dependent probabilities. Okay, so for my year 10 set 4, I'm expecting you all to be able to do the drawing and the labelling. Most of you should be doing the independent and be able to do all of this video. The next video you might find a bit trickier because that's your grade 5, but I think it's doable. Okay, it's just the type of question that's more likely to trip you up in an exam, not something that you can't do yourself. Right, so starter. This is based off the work you did last lesson, so pause the video, just check you can do this. Okay, so you should have paused. You're flipping 2 fair coins, probability of flipping 2 heads. Now it said you can draw a diagram or a table if it helps you. So I probably would have drawn a diagram and I would have got H, H, H tails, TH, TT. Okay, 2 heads, 1 out of 4. 1 tail, 1 head, 2 out of 4. Yeah. So, straightforward, easy enough reminder from last lesson. We're moving on, and something that you might have talked about last year, and this is the AND rule with probability. So, we're going to look at, and it's to work out the probability of 2 events both happening, considering their individual probabilities. So, if we have a look, the first coin, the probability of getting a head was a half. It was a head or a tail, it was 1 out of 2 options, easy. And the same with the second coin. Now, when we did the starter, we knew that the probability of getting 2 heads was, sorry, I didn't write that in. 2 heads was 1/4. Okay, so 2 heads was 1/4. Can you spot the link between these 2 numbers here and this number here? Hopefully you'll have spotted that you just multiply. 1 times 1 is 1, 2 times 2 is 4. Remembering that when you're multiplying fractions, you just multiply the numerators together, multiply the denominators together. Great. So the probability of events A and B happening are multiply the probability of A by the probability of B. Okay, and I've just shown you why on a basic level. Just trust me. Okay, so tree diagrams. We were happy with the sample space diagrams. They were nice and straightforward. However, I did mention in the last video that they were straightforward because the probabilities were all the same. So heads and tails, the probability was a half. We did spinners where I said you've got to assume that they are fair spinners. It was a third, a third, a third. It was a fifth, a fifth, a fifth, a fifth, etc. Okay, there was nothing different about all of them. Okay, so tree diagrams, you can have probabilities that aren't the same. The first question we're going to go through, they are the same. So, but that's just to make it easy. And sometimes it's easier to use a sample space diagram. It's also used because with the sample space diagrams, you can have 2 events. Okay. If you added a third event, you can't really draw that on the diagram. You need to kind of go 3-dimensional. If you had a fourth one, you'd have to go 4-dimensional. It would be, pretty impossible, really. However, tree diagrams, you can keep adding to, you can keep adding complexity levels, and it's still the same structure. Okay, so it works nicely. And what we need to know is that you can multiply along the branches. So, tree diagram. So we're going back to this flipping of 2 coins. What's the probability I get 2 heads? So the first event that is happening is the first coin flip. And for the first coin flip, there's two options. There's heads and tails. So on coin 1, that's event 1. That's my first thing that happens. I can get heads or tails. And we know the probability of a heads or a tails is just a half and a half. And we write that along the lines. Now, my second event is me tossing the coin the second time. Now you can see there's kind of like two parallel universes running on. So if anyone that is super geeky, every choice, there's this idea that every choice you make, you create a parallel universe where you made another choice instead, and then it branches off. It's that kind of idea that we've got one world where I got a head on the first one, and we've got one world where I got a tail on the first one. So we're going to go into the heads world first. So I got a heads on the first one. Probabilities add up to 1. My second event, I could get a heads or a tails on the second coin. Again, a half and a half. And that's my only options if I got a heads on the first one. But I could have got a tails on my first one. So if we go back into the world where we've got a tails on the first one, I could get a heads or a tails for my second coin, and the probabilities are still a half and a half. Okay. Then if we remember what it said right back at on the last slide, it said you have to multiply along. I want the probability of getting heads and heads, so I have to multiply. A half times a half is a quarter. You just multiply the top and the bottom, remembering this notation from last time, probability of a head and a head. And then I do the same for the rest. Heads then tails, quarter. Tails then heads, a quarter. Tails then tails, a quarter. Okay. And then possible outcomes are shown at the end here. We multiply along the things. And the probability of getting 2 heads was just a quarter. If I wanted the probability of getting a head or a tail, it would have been those two added up. Okay. So, that's an easy example. Sample space diagram would have been quicker and simpler. The next one we couldn't do in a sample space diagram. So, the next one, we've got counters in a bag. We've got 3 blue, 7 red. I pick one counter out without looking, so it's a random fair sample, and put it back in the bag. So what's really important is put it back in the bag. Next lesson, we'll look at when it's not put back in the bag. Okay, so when it's put back in the bag, it's independent. When it's not put back in the bag, it's dependent, and that's the next lesson. Okay, I then pick out another counter. What is the probability I pick out a red counter and a blue counter? Okay, so first time I pick out, I have 2 options that it could be. So my first event, counter 1, it could have been red or it could have been blue. Now, the probability that it is red, well, there are 7 red counters out of 10 counters in the bag. So that's 7/10. And then there are 3 blue counters out of the 10. Then for counter 2, in my first world, I could have got a red. Then I could get a red or a blue in my second world. Now remember, I put that red counter back in the bag, so there are still 7 red counters in the bag, which means there are still 3 blue counters in the bag, 10 counters in total. So those probabilities are the same. Okay, if I didn't replace it, it would be different. That would be dependent. That's in the next lesson. Okay. I could go back in time. I could have gone down this path instead, and I got a blue and then a red or a blue. Get my probabilities. Multiplying across. Remember, multiplying numerator by numerator, denominator by denominator. So that should be 49 over 100 for the probability of a red and a red. Red and a blue should have been 21 over 100. Blue and a red, 21 over 100. Blue and a blue, 9 over 100. Okay. So what's the probability I pick out a red and a blue? Well, red and a blue happen twice. Okay, so they happen here and here. It doesn't say that it's fussed about the order that it goes in. So I can just add those 2 probabilities up, 42 out of 100. They then simplified. So with the simplifying, I think I mentioned this last time, you don't have to simplify your probabilities. Actually, in tree diagrams, don't simplify until the very end of the question if you want to do any simplifying. Because these don't simplify nicely. But if they did, you'd still want to be adding them up, and then they'd have to have different denominators, which would be a pain because you'd have to make the denominators the same. However, if you've done this, the denominators are all the same, so then you can add them up easily. Okay? So I would just leave these as they are. Don't simplify. So that's some of them. That's my explanation. Oh, my battery's running low. I need to go and grab my charger in a second. So, last lesson, at the end of the lesson, I gave you a word that I wanted you to write back in your comments on Show My Homework. This time I'm just going to give you letters throughout the video so that you can then build up the word by watching the whole video and then message that to me at the end. Okay, so that I know you've watched the whole video and not just skipped to the end. So at this point, I'm going to give you the letter S. So the first letter is S for sugar. Right. There's tasks. So they're kind of 3-level tasks. There's a few questions of each one. I think I've got 4 questions in total. 1 bronze, 2 silver, 1 gold. So bronze is kind of grade 3-ish. Silver is kind of grade 4-ish, and kind of the yellow is moving towards the grade 5. It's slightly more complicated diagrams. So, bronze. I want you to read this. I want you to try it on your own. And pause the video now. I'm going to quickly go and grab my charger. Shuffling around in my slippers. Right, there we go. So, bronze. Probability that Neil wins a game of chance is 2/5. He plays 2 games. He completes the tree diagram below. So, game 1, he could win or would not win, is 2/5 and 3/5. Game 2, the probability he could win is 2/5, which means the rest has got to be the probability he doesn't win. So remember, probabilities have to add up to 1. 2/5 he doesn't win, then that means that 2/5 he does win, means that 3/5 he doesn't win. Back in time, he didn't win his first game, but he could win his second game. Now these probabilities here and here have to be the same. These two don't have to be the same. They happen to be for this question, but they don't have to be. These have to be. No, they don't. They have to be if they're independent. They don't have to be if they're dependent. We'll talk about that next lesson. 3/5. So, notation, probability of a win and a win. 2/5 times 2/5. 2 times 2 is 4. 5 times 5 is 25. So then the probability of a win and then a lose. 2 times 3 is 6 over 25. The probability of a loss and then a win is 3 times 2, which is 6 over 25. And then the probability of 2 losses, 3 times 3 is 9 over 25. Find the probability that he wins both games. So win-win, 4 over 25. The probability he loses both games, 9 over 25. So that's kind of your grade 3, 4 kind of question. Okay, so let's have a look at the next one. So I want you to try this one. So pause the video, try it. Oh, before you pause it, I'm going to give you a letter. I'm going to give you the letter P. I'm trying to think of what that is on the P for, I want to say Pongo. Doesn't really help. P for pounce. Obviously been watching too much Lion King. Right. Pause the video, have a go at the question. Okay, so we've got people that are bad at attending school. So Anna. Probability she attends school is 3/5. Which means the probability she doesn't attend is 2/5. Okay, that's a very low percentage. That's a 60% attendance. That's not very good at all. Okay. Bill then. Bill, he could attend or not attend. Ugh. And then he could attend or he could not attend. Okay. So, probability that Bill attends school is 7/10, which is 70%. That's slightly better, which means the probability he doesn't attend is 3/10. And that's the same, as I said, if it's independent, it's the same for both. Okay. So the probability that both of them attend, so attend, is 3 times 7, which is 21, 5 times 10, which is 50. The probability that we've got an attender and then a not attender is 3 times 3, which is 9 over 50. The probability that we've got a not attender and a attender is 2 times 7, which is 14 over 50. And the probability that we've got a non-attendant and a non-attendant is 2 times 3, which is 6 over 50. Okay. Find the probability that neither is at school. So that's neither of them at school, 6 out of 50. At least one of them is at school. So, keywords here, at least. So that could be what Anna's not in but Bill's in. Anna is in but Bill's not. Or Anna and Bill are both in. So that's all of these added together, and all of those added together should be 44 over 50. What we should notice is that those two add up to 1. Okay. And if you have a think about it, you might be able to work out why. If you can't, send me an email and I'll let you know. Okay. So that one is kind of one of your kind of silvery kind of questions. Got another silvery question here, because you've got to draw it yourself. So for this silvery question, I'm going to give you a letter, another letter. I'm going to give you the letter A. A for alphabet. A for apple. A for alpha. Well, see, I can do lots of A's. Pause the video, have a go. Okay, so Melanie is a sixth form student who has 2 classes with homework due on a Tuesday. The probability she has her maths homework is 2/5. The probability she has her English homework is 7/10. Draw a probability tree in the space below. So maths and then English. They're independent. Whether she has a maths homework doesn't affect whether she's got her English homework. Okay, and clearly she likes English better, or English homework's easier to do. Anyway, maths. So she either has or doesn't have. Oh, come on, pen, work. You were just working. There we go. Have or not have the homework. If she has her homework, that's 2/5, which means the rest has got to be not have, which is 5/5. Now, she could have her English homework and has her English. Sorry, she could have her maths homework and has her English homework, or she could not have her English homework. Or she could not have her maths but have her English. Or she could not have her maths and not have her English. Okay, so her English homework, the probability she has it is 7/10, which means the probability she doesn't have it is 3/10. Remember, these two have got to add up to 1. Here, again, 7/10 and 3/10. If they're independent events, these guys have got to be the same. So, probability, has and then has. Oh, come on, pen. Okay. Has and has is 2 times 7, which is 14. 5 times 10 is 50. Probability is has and then not has. 2 times 3 is 6 over 50. The probability of not having and has is 3 times 7, which is 21 over 50. And then the probability of not having and not having is 9 over 50. Use your diagram to find the probability of no homework. So that's this one, 9 over 50. Only one piece of homework, so that's this one and this one, so that's 6 over 50, plus the 21 over 50, which is 27 over 50. Okay, right. Gold. So a hard task. You can see that this one is harder because it's now got 3 options, whereas all of our other ones have only had 2. But that's the only thing that makes it more tricky. It's just a bit bigger. Actually, it's exactly the same in kind of structure and everything. Okay, so I'm going to ask you to pause the video. I will give you another letter in a minute or so. Have a go. Okay, so hopefully, now in an exam I would write out purple, and I would write out green and yellow all in full because I'd take my time, but I'm going to be lazy. Now, I could mess up these orders, but I think that might be more likely to make me make mistakes, so I'm not going to. Okay. Again, we notice this word replaced. Your next lesson will be non-replacement. So we've got 3 purples, 2 greens, 5 yellows. So 3, 4, 5 plus 5 is 10, so that's 10 counters in the bag. So that's 3 out of 10, it's 2 out of 10, 5 out of 10. Now, because they're all put back in, the second time I pick up, it's exactly the same. So 3 over 10, 2 over 10, 5 over 10, 3 over 10, 2 over 10, 5 over 10, 3 over 10, 2 over 10, 5 over 10. Okay. So, probabilities. I'm going to give you a letter right now in the middle of a question. I'm going to give you the letter C. C for cat. And I'm going to tick off that I've given you the letter, otherwise I'll lose track. Right, now we want the probability that both are purple. 3 times 3 is 9, 10 times 10, 100. The probability I get a purple, then a green, is 6 over 100. Again, just timesing. Probability of purple, then yellow, is 15 over 100. The probability of green and then purple is 6 over 100. The probability of green and green is 4 over 100. The probability of green and yellow is 10 over 100. You know, I could cancel these down, but it'd just make any work later on harder, so don't bother. Probability of yellow, then purple, is 15 over 100. The probability of yellow and green is 10 over 100. And finally, the probability of yellow and yellow is 25 over 100, so clearly the most popular. Now, they haven't actually asked any questions from here. They could ask a multitude of questions for this one. They could ask what's the probability of having all the same colour. So that would be this one plus this one plus this one. So whatever that adds up to. It could be what's the probability of getting a purple and a yellow, which could be this one plus this one. It could be what's the probability of getting a green, which would be this one plus this one plus this one plus this one plus this one. You know, there's loads of different combinations that it could be. Okay. Right. Go online if you want to find any more questions on this to practice with. Okay. So, aha, we're at the end. Woo! I'm going to, so if you were to self-assess yourself, could you now draw and label a tree diagram as an absolute minimum? If you can't do the probabilities, do you think from a question you could be able to draw and label one? And that would give you your grade 3. Grade 4 on it, could you do the independent stuff, all the kind of questions we've done? And then grade 5 is what we're going to be doing next lesson. The next lesson is dependent probabilities. Okay, I'm going to give you the last letter. If you're only just tuning in now because you wanted the word at the end of the video to message me to tell me you'd watch the whole video, tough. I'm only giving letters. I'm giving letters out throughout the whole video, so you have to watch the whole video to know what the letters are and what it will spell. I'm so mean. So the last letter is the letter E. Okay? So the last letter is the letter E. E for elephant, E for egg, E for echo. So I hope you now will be able to do basic probability trees. Next lesson we'll be doing independent probability trees. Nice and tricky. Okay? So, see you later.